I'm jumping on ring, ring, ring.
The universe. It's everything we know to exist in what we call...
Hey, what are you laughing at? Sit the hell down. You may continue.
the cosmos. Behind me, the Milky Way galaxy, a small fraction of that universe.
Hey, cut back
Within
to the
it,
handsome
our
guy.
solar system and our planets. My research is about connecting those planets to discover life. Specifically,
Hell
on
yeah,
Mars.
life is rad.
Mars is interesting to humans for a long time because it's the planet in our solar system that is most like Earth. Early in the history of Mars, it looked a lot more like Earth. Vast oceans, volcanoes, plate tectonics. But the atmosphere of Mars deteriorated, the oceans dried, and it became the red dust ball that it is today. The areas on Mars that I'm interested in is the Nili Fossae region and the Isidis Basin. That's because they contain a mineral assemblage known as olivine and serpentine. And that's significant because they're common right here on Earth. Sometimes, the Earth's mantle is primarily composed of the mineral olivine. Sometimes through plate tectonics, that olivine is uplifted through the Earth's crust and deposited onto the surface. An example of this is at the Coast Range Ophiolite.
Jeremy, we don't need more rocks. But I don't have this one. Ha!
The McLaughlin Reserve in Northern California. The olivine in this area reacted with the groundwater to create the mineral serpentine. At that area, the groundwater is, because of that process that we call serpentinization, is highly basic. It's about an average pH of 12.5, much more so than your average household ammonia.
Hey, can you drink it? No, you idiot. Sorry.
Area, we have 9 groundwater monitoring wells where scientists from all over our country come to study the reaction between the process of serpentinization and this environment. That word environment is important to my research. I mentioned earlier the cosmos. As humans, we have the perception to understand the universe as our environment. If you asked an ant, he would probably say his environment is a hole in the ground. It's all a matter of perception. For my research, I took an environment and sucked it down into a bottle, which we call a microcosm, or a tiny universe. The basis for this universe is the mineral serpentine. The other component for an environment is an atmosphere. We use 6 experimentally relevant atmospheres that are relevant to that process of serpentinization that I talked about. The first atmosphere is a vacuum like in space, hydrogen atmosphere, carbon dioxide, hydrogen and carbon dioxide, methane atmosphere, and a hydrogen and methane atmosphere. And then the last component of the environment, probably the most important for an environment that can sustain life, is water. We used distilled water, surface water from the McLaughlin Reserve, which is mainly rainwater, and 5 different wells, each with its unique chemistry that could increase the habitability in these samples. But who are these for? What did I make these environments for? I made them for these guys. Microbes and bacteria, the most basic organisms of life. And the objective of my research is to determine whether they have a particular affinity to one of those environments, if they're utilizing the mineral components of those environments, and are they changing them in a certain way? Do they alter the minerals? Do they leave a trace on those minerals so we can detect them?
Hey, do I get a bathroom break? No!
Once they're gone. And then finally, what part of that whole process of serpentinization might contribute to the microbial growth in the samples? My hypothesis for which is that in the different environments, there may be different microbes that have a higher survivability in a particular environment, and that there will be different amounts of growth within those samples. So what have we found so far? So far, there's a detectable amount of nucleic acid.
Whoa, 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 wait a second. Hold on. I know for a fact I've done more work than that. Excuse me. You there in the back? Excuse me. Can you bring up that other chart, please?
Yes, sir.
Where's that? Thank you. All my hard work. Right there. What happened? Well, I'll tell you what happened. Cuts off my head. Ah, shit. Cuts off my head. I'll do it. Now, since I did this, I've done a lot more work, obviously. Okay? Now, I've compiled all the data from all the wells that I had sampled, and these are the full results that I got. Okay? And you see that huge peak over there. That blue peak? Huge peak. That is what I call a result. Alright? That's what I call a result. Alright? And I did what's called it's a statistical test that says my data is relevant. It's different enough that it says something. So what we've found is that in my samples, whether it be because of different aqueous chemistry or what have you, that there is a difference in the amount of growth. Obvious in that peak right there, that is in methane. Now, I'm going to give it back over to the handsome devil that was in the tie, and be right back. Back to the show.
The basic building blocks of DNA. So there is life in the samples. In the graph, you see the most amount of growth we've seen so far is in the environment in a vacuum, which is interesting. We also used a scanning electron microscope to look at those microbes on those mineral surfaces, is to maybe see
microbes,
directly
rad!
in contact with a particular mineral that they might be utilizing for energy. And we believe that they might be using iron-rich minerals for energy. And finally, we used a technique of staining these microbes with a fluorescent dye and looking at them under a fluorescent microscope and typically this method is used to determine cell counts, cell density, how many there are in a sample. Because of the lack of density, it wasn't apparent a good way of doing it. But you can see that we might have seen groups of these microbes, or they might be colonies that are metabolizing clay minerals that are remaining in the sample. Now, why is all this necessary? What's the purpose? Research on Mars is extremely expensive. Back in 2012, the Curiosity rover cost $2.5 billion. It's also very time-consuming. I know some of the people that control the Curiosity rover, and for 8 hours the rover is operating, they go back, review all that data, send it to the pertinent people to study, and then have to figure out what the next steps for the rover are. And you're also limited by what is on the rover. There's no, I forgot my microscope at home. On Earth, we have that ability. The research is cheap, travel is easy. It's fun to camp out in the field, even though sometimes you have to stay in a warehouse that looks like it's from Jurassic Park. Luckily, no velociraptor attacks yet, but you never know. And like I said, you're limited to what's on Mars. So how is all this new research relevant? Because in 2020, NASA is putting another rover on Mars, and
Hey, I have some questions about the Mars rover. How many wheels does it have? Does it have any cameras? Is it named after a dog? Can it fly? Can it die when it crashes? What are you going to do? What if it does crash? Or can...
Hey, sit down! Save your question until the end, please.
new technologies are being added to the rover all the time. The locations for that rover are possibly the Nili Fossae region and the Isidis Basin, which is the focus of my research. And the number one question that they're trying to answer, the first scientific goal of that mission, is to determine whether life ever arose on Mars, and my research directly answers.
Hey, wait, where are you going? Hey, come back! Aw. Thank you, everybody, for watching this episode of Bro Team Games. This was my Think Big Tank presentation. If you like this... Hello, Isaac's here too.
Hi.
I got a green screen, obviously, since we're not... Hold on.
I played the annoying kid.
What? Anyway, so we got a green screen, obviously. Pretty cool. Anyway, so this was my presentation. If you like this, if you have questions about my research, you can leave them in the comments below. You can obviously contact me, not him, he's stupid. And, what? Oh, did I hurt your feelings? Good. Anyway, you can ask me any questions you want, and we'll see you guys
In the next video.
Bye-bye.
Give me a baby!